Okay, so hello everyone, welcome. Can you hear me? Hello. Okay, so you're waiting 1 minute for joining all of those other participants. Then we'll start today's session. Okay, so we'll start today's session. Okay, I think some people are also busy, so that's why they cannot join. So okay, they also get the recorded class and cover this part. No problem. Okay. Okay, so basically today's session, I also try to discuss about that change detection. How we can easily perform the change detection using Google Earth Engine platform, mainly land use land cover change detection, as well as also NDVI change detection, or any kinds of change detection analysis, how we can easily perform using the Google Earth Engine platform. So these things I also try to discuss, as well as I also try to discuss about the hyperparameter tuning, so develop our machine learning model algorithm. So these things I also try to cover for today's session. So let's go. Just I simply share my screen. Okay, so now can you see my screen? Is it visible? Okay, can you see my screen?
Yes, sir.
Okay, thank you. Okay, so now we'll start. Okay, so let's go. Okay, so basically today's session we try to discuss about that one kind of mainly you can see NDVI change detection. Suppose you have a 2 decade NDVI map. One is the year of 2020, another is the 2015. Okay, so now we can easily make the change detection. How much NDVI will be increasing or decreasing, and which part vegetation will be increasing. So these type of things we also try to cover for today's session, as well as we also try to discuss about the change detection. Suppose you have a 2 decades land use land cover classification map such as LULC 1991 and LULC 2021. So now you want to make the change detection analysis between these two map and try to calculate it, how much area will be increasing or how much area will be decreasing. So these type of things we also try to discuss for today's session, as well as we also try to discuss about the hyperparameter tuning to develop our accuracy, mainly in this time hyperparameter tuning is that what is the base decision number of trays. Okay, we try to find out the base decision number of trays and also use it, then we also get the better accuracy. Okay, so basically this today's session try to discuss about the three topic. One is the change detection for NDVI, another is that mainly how we can easily perform the change detection from 2-decade land use land cover classification map, as well as also try to discuss about the hyperparameter tuning. Okay, and basically today's session we try to discuss, as well as we also try to discuss about the class wise land use land cover change detection in one layer using Google Earth Engine platform, and hyperparameter tuning out for improving the accuracy of our machine learning model. Okay, so let's go try to discuss one by one all of this topic. So first of all, we start from suppose NDVI change detection. Okay, how we can easily perform the NDVI change detection, and we already know about that how we can easily create the NDVI map. Okay, we already covered this part, how we can easily call the land set image, and then we are just applying this type of formula, mainly near minus red divided by near plus red. Okay, so we already know about that how we can easily calculate the NDVI. Okay, so now I will show you that how we can easily perform the change detection analysis for NDVI. Okay, so in this time you can apply the two approach. One approach is that you can make the class of NDVI and you can also make the change detection. Suppose you can simply search on the Google, suppose NDVI class. So in this time we are also get some different types of thresholding value, and we can get the some class of NDVI. Suppose this range is that water, you can see this type of class we can get from here. You can see the less than 0 is the water, 0.03 to 0 is the bare soil, then 0.03 to 0.3 it's the sparse vegetation, 0.3 to 0.5 it is the moderate vegetation, greater than 0.5 it is the dense vegetation. So basically in this time is the pixel range. Okay, so if you want you can make the pixel range, mainly use the different types of pixel range and create the different types of class. Okay, suppose here you can see all of those pixel greater than less than 0 it show the water. Okay, and 0.03 to 0 it show the bare soil, then 0.03 to 0.3 it show the sparse vegetation, and 0.03 to 0.5 it show the moderate vegetation, and greater than 0.5 it show the dense vegetation. So in this time if you want you can just make this type of class on your NDVI map, which I already created for 2 time period. Here you can see I already created the NDVI map. In this time we are applying this type of pixel range and make the class. Suppose I make the class for water, bare soil, sparse vegetation, or moderate vegetation, or dense vegetation. Just use this type of pixel range, and then we can easily make the class of NDVI. Okay, and then we can easily make the change detection of NDVI. So let's go, we try to show you that how we can easily make the class of NDVI. So for that, here you can say I already make the map of NDVI 2000 and 2015. Okay, so let's go try to apply these things. So here you can see NDVI 2020. So basically this variable stored the NDVI map for 2020. Okay, this map is stored in the NDVI 2020. So in this time this map I want to classify. Okay, so I want to classify for the different types of classes based on the pixel range. Okay, you can see the different types of pixel range, you can easily find out. So in this time I want to use a pixel range and create the class of NDVI. So for that it's very easy for the make the class. So I just take the comment, it's a NDVI class. We make the NDVI class different based on the pixel range. So for that just take a variable. Suppose I put the variable name is that NDVI class, suppose 2020. Okay, I take the variable name, you can put any name, then call your NDVI map. So basically in this time NDVI 2020 it is stored in this variable. I simply copy and paste here. Okay, and now I just use it and I want to make the pixel range. So different types of pixel range I want to use and then make the classification. So for that first of all I just use a function, this function called ee.image. Okay, and then put here that 0
reference local about working on the relay elevation map.
Okay, so kindly mute. Okay, we'll start. Okay.
Oh, what could you say?
Okay. So in this time, we'll just make this type of class. Suppose I just use a function ee.image then 0, and then in this time we are apply the higher function. Okay, using the higher function, we are just make the class. Suppose in this time I want to put the function higher and call this NDVI 2020. Paste here this name of variable. I put here the NDVI 20 greater than suppose 0.0, and also put here the AND function and NDVI 2020 suppose less than equal suppose 0.2. So just put here the 0.2. So in this time here you can see I just put the higher function and call the NDVI greater than 0.2 and NDVI less than 0.2. So I put the one kind of range, suppose 0.0 to 0.2. So this is the one range I apply. And further I want to apply the more range. So further I simply copy the same line of code. And further I put here that, and then I simply change the name. Okay, value range value. Suppose I put the NDVI greater than, put here the 0.2 and 0.2, I remove that 0.2, and then NDVI less than equal, suppose put here the 0.4. So it's my another class. Okay, suppose I put the another class for NDVI 0.4 to less than equal 0.6. Okay, suppose then I put here the NDVI less than equal greater than 0.6 and less than equal 0. Suppose I put the range for 8. Okay, and further suppose I want to make the another class which is the greater than 0.8. Okay, so for that is very easy, just I simply remove this part, it's not need. I just put here the NDVI greater than, only put here the greater than, mainly suppose put here the 0.8. Okay, and stored these things and put the parenthesis. So in this time here you can see, so first of all I just use the function e.image 0 and call my NDVI 2020, then put at the greater than 0 and NDVI less than equal to 0. So it's make a range 0 to 0.2, 0 to 0.2, then 0.2 to 0.4, then 0.4 to 0.6, then 0.6 to 0.8, and final class we consider all of those pixel greater than 0.8. So in this time we are just make the name about that. Suppose I put the name, it's the class number 1, I put the class 1, this name I put the class number 2, this class I put the class number 3, and this number I put the class number 4, and finally I put the class number suppose 5. In this time this NDVI map 2020 we are just classify into total 5 class based on the pixel range 0.0 to 0.2, then 0.2 to 0.4, 0.4 to 0.6, 0.6 to 0.8, and greater than 0.8. So we try to make the total 5 class. So in this time it's indicating the high vegetation. Okay, class 5 is indicating the high vegetation, then sorry it's a very high, then high, moderate, low, very low. So in this time we are just this type of sequence we can follow. So 5 is indicating the high vegetation. So now let's see, we try to add the visualization about our classification map. So for that I just simply use add the map.add layer function. Okay, and call this NDVI class 2020 and paste. Okay, and suppose in this time I just simply choose my study area. Suppose in this time I simply draw my study area. Suppose I simply, or if you want you can simply put your shape file, no problem. In this time I simply, suppose it's my study area, this is my study area, and I want to observe the make the NDVI class only for this boundary. So for that I just simply clip with my shape file. So just I put here the clip and put the boundary variable name. Boundary variable name is mainly boundary. I put the name is the boundary. I simply copy the boundary and paste here, just clip with that. Okay, and now further I just try to add the click to the run. In this time it added the map. We can get the classify map without color combination. So in this time we can get this type of map. Here you can see we can get this type of map, and it represented the NDVI classification map. Okay, and I want to classify according to this base pixel range. Okay, so in this time we add the color, then we also get the more better map. So for adding the color, different way you can apply. If you want, you can simply click on here, and further you can see the constant value. So in this time we are just applying from suppose we have just put here that plated option. Just click on the plated and then put here that suppose I put the color. So basically in this time it show the blue color, so I need to show the blue color. Then put here that suppose this type of okay, suppose put here this type of yellow color. Then put here the suppose this type of white color I apply. Then suppose I want to put this type of pink color, and finally I want to show this type of suppose or this type of green color. So 1 2 3 4 5. So then apply it. Okay, so now it create this type of map we can get from here. Okay, so in this time it show about the mainly show about your water body. We can get this type of things. Okay, class number 1 water body. Then we can easily get that dense vegetation. I think it's not much dense vegetation. So okay, just I try to add the remove the one color, and I put this, it's a green color. Now try to check. Okay, so in this time we can get this type of vegetation in here. Okay, or we are just simply copy these things from here, and we have to mention. Okay, so we have to mention our class friends. Okay, let me check. So in this time we are just put here that curly bracket and put here the mean. Basically in this time our class will be start from the 1. Okay, 1 to 5. So just put here the mean is the 1 and put here the max suppose 5. Okay, so now further click to the run, and now going to add the color easily. In this time I also get the more better result when I want to add the color. So now further just click on here, and now it show about the 1 to 5. Okay, so now we can get the proper range. It will be start from the 1 and 5. 1 is represented the low pixel of NDVI, so it can be water body or other things. So I show this type of blue color. Further greater than I want to show this type of things. I want to show suppose this type of yellow color. Further I want to show this type of for this class number 3 I want to show suppose this type of green color, and for class number 4 I want to show suppose this type of color, and for the class number 5 I want to show suppose this type of green color. Okay, high green color I show. So now further apply. So now we can get this type of map. Here you can see we can get this type of things is the vegetation. Okay, so in this time it create the classification. So we can get the one class, it can be this type of water body, and we can get the yellow, then we can get this type of color or this type of color. Okay, so now it represented the classification. In this time we create the total 5 class of NDVI map. Okay, so further if you want, you are just import these things, or if you want you can simply add the plated. You can see it already added the new, so just I simply copy from here, copy. Okay, it's a 2, so I take this from first, simply copy, and further I just simply remove the previous. I simply remove that and paste here. Okay, and I put this name, it's the NDVI class 2020. So now click to run. So in this time it created the NDVI class map for 2020. Okay, classified according to this range of NDVI. So this is the process how we can easily create the classification. So using this process, you can easily use the any kinds of thresholding pixel range, and you can easily apply this thresholding and make the classification map. So here you can see we create this type of map of vegetation, and this map is year of 2020. So now do for the same things for 2015. So for that we are just copy this same code. Suppose I just simply copy from here, simply copy this same code and paste, and I change the name. Suppose it's a year of 2015, and I call the NDVI map 2015. Here you can say I already create the NDVI map for 2015. So this is the map for NDVI 2015. I simply copy this variable name NDVI 2015, and further we are just using here. Further just simply put here that NDVI 2050 greater than 0 and NDVI 2050 less than 0.2. Simply paste, copy and paste, then we can get the result for 2015. Okay, and further simply call the NDVI class 2015 and paste here. And clever, I use simply put suppose the year of 2015. Okay, so now further click to the run. In this time it create the NDVI class map year of 2015. So here you can see in this time it create the two map for NDVI class map year of 2015 and 2020. So now we can easily perform the change detection analysis using this two maps. Suppose here you can see it create this. Okay, you can see this is the one class, and we are use the same NDVI pixel range. Okay, we are also get the more change between these two time period. So first map, this map, it show the result of year of 2015, and this map show the result of 2020. So here you can see we can easily identify from the visualization there are a lot of changes. Okay, you can see this part have the lot of changes between the year of 2015 to 2020. Okay, so in this time I show you that how we can easily make the change detection. Suppose I want to show how much class will be increasing or decreasing. Okay, so before showing these things I also talk about the LULC, because LULC change detection and this type of change detection is the almost same. So in this time here you can say I already created the LULC map. Okay, so basically this map we are already classify the two land use land cover classification. In this time we can create the map LULC 1991. It's a 1991. This is the map of LULC, and this is the map for 2021. Okay, so in this time I already make the class. Suppose water, build up, vegetation, and others mainly barren land. Okay, others mainly barren land. We make the class of water, build up, vegetation, and others 2 decade 1991 and 2021. So now I want to find out the change detection, how much area will be increasing for build up, how much area will be decreasing. So this type of things in this time I also try to discuss, and further I also back to the NDVI class. Then you can easily relate the two things at the same time. Okay, so in this time here you can see I already make the classification of the two classes. So in this time first of all we can do the single class change detection. Suppose single class change detection, it means that you want to make the change detection only for the urban area. Okay, how much urban will be increased. So it's called the single class. Suppose I want to make the change detection for the single class, and then I want to calculate the how much urban area will be increasing and where the urban will be increasing. This type of place I want to identify from my map, or urban growth development. Okay, or urban spiral mapping. So these type of things we can easily do in Google Earth Engine platform using the we can easily do. So first of all we try to discuss about that single class change detection. Okay, single class change detection means that in this time we are just talk only for the one class. Okay, and then we are just make the classification. So in this time I write the code again, it also better to understand. So in this time first of all we talk about the single class change detection. Okay, suppose I want to identify about the urban growth. Okay, So in this time here you can see we already make the map of two map. One is the 1991 and one is the 2021. So now I want to make the how much area in 2021. I want to calculate this area. Okay, single class area. So for that, first of all, I just need to take a variable. Suppose I put a variable name is that build up area. Suppose 2021. Okay. So now here you can see we already make the build up area. So in this time, this type of red color identify about the build up area or settlement. So in this time, I need to call this map LULC map 2021. So I already stored this map in a variable. I need to find out this variable name. So this variable name is that classified RF 2021. Okay. So basically this variable stored this map. Okay. So I simply copy this variable name and paste here. Okay. So then equal to, in this time I put here the EQ, it means equal. I need to set equal to number of build up. Okay, here you can see when I take this training sample, I put the value 1. Okay, also you can see we use the same value for build up 2021 1. Okay, so build up area is the 1. So in this time I set equal to 1. So it is the build up area. So now I just try to show the build up area on my map. Suppose I want to create the single class map of build up area or settlement area I want to identify from my map. So for that I just add a layer. So map dot add layer and call this build up area. Simply copy and paste here. And now I want to show the result. So I put here the mean. It will be 0 and max 1. And put here this plated function. I show the plated mainly where there is no urban, it show as a gray color, and where this is urban is present, it show as a red color. And I put this name, it's a I put the name, suppose it's a urban or settlement 2021. I put the layer name. So in this time you can say I click the run. Now it created the one layer. This layer mainly show you that urban area map in 2021, only urban area it visualize. So it working. So just I open this layer. So in this time it create the urban map 2021. Okay, it working. I think some networking issue. Okay, I think some networking issue, so that's why it's not loaded. Okay, so now try to check. Okay, so now it's working here, you can see. So I hope you can also hear me. Sorry for networking issue. Okay, so here you can see now it's loaded this map, and in this time it show you only for that build up area. Okay, so just I simply take a variable, and further we are just call the land cover map for 2021. We simply call this map and then set equal to 1 mainly it's our value. Okay, build up area value, we put the 1, so set equal to 1. And further we will show about that where the build up area is present, we show this type of gray color, there is no build up area, and red identify about the build up area is present. So here we can get the put the layer name. So now it show about that build up area map in year of 2021. So now suppose in this time I want to calculate the how much area in the build up area. So calculating this area, we'll just use the code. Basically I take a variable, suppose build up area. I put this build up area, suppose 2021 equal to, I just simply call this variable name and paste here. And before that we have to use a function ee dot image dot pixel area. Okay, and then just use a function, just use at the multiply function, multiply with this name, variable name. Okay, build up area, multiply these things. So now we are just show the result. Take a variable, suppose area, and call this build up area 2021, paste here, use a function reduce region. Okay, so basically this function calculated the specific boundary, any kinds of statistical value, it can be minimum, maximum, or total. Okay, so in this time we'll just put all of those argument one by one. So curly bracket start, and also curly bracket in here. And for that, first of all, reducer, in this time we are just put here the reducer value. I have to calculate the total area, so use here ee dot reducer dot sum total area, and your geometry. So basically geometry mainly it show the ROI, or you can check the variable name about that. This is AOI. Okay, this variable name is the AOI. So just I put here the AOI, it's our boundary shapefile variable name. Put here the AOI, and first of all scale mainly in this time we got the land set imagery, so 30 meter we put in here, and for the node I remove that. So now in this time we are just click to the print that area, so print this area, print, and call this variable name area, click to the run. So now it computed the total area in year of 2021 for settlement, how much area we can get this result, and this result we got the result in square meter unit. So in this time we can get this result, you can see it show this result in here. It computed as a dictionary. Okay, you can see we can get the result as a object, and here you can get the area is the square meter. So here you can see in this time we are just applying these things in here. So basically in this time it show the result in square meter. So in this time we can easily convert this unit in square kilometer. So further we are just divide with 1 is 6, then we can get the result in square kilometer. So for that we are just take a variable. Suppose I put the variable name is that urban area, suppose 2021 square kilometer. You can put any name as a variable. And now this number I want to convert into square kilometer, and it's a number. So further we have to define the number function. It's called the ee dot number. Okay, and further I call this area. Simply copy this variable name and paste here, and then this number I get from this area. Okay, so just I put here the get and call this area. So just I write here the area. Okay, and now these things I want to convert into a square kilometer. So for that we are just put here the divide function. So use here the divide with 1 e6. So now further I just print that area. Suppose I print this urban area square kilometer. I simply copy this variable and paste here. So now it computed the area in square kilometer unit. How much area for the urban or settlement. So here we can get the 74.93 square kilometer area. Okay, or if you need only for the integer value, so you can use here the round function. Then you can get only for that integer value. Okay, round figure. So put here the round function and click the run. In this time we can get only for the integer value. How much area? We can get the 75 square kilometer area. Okay, in